Hi everyone, welcome back. So now that you know a little bit more about what shadows are, we're going to talk about how to cast shadows in an orthographic drawing. We'll start out with some basics of how to cast the shadow of a point, a line, and a plane, moving on to three-dimensional solids, and finally, how is this applied to architectural drawings? We'll take a look at plans and elevations. In our last video, you learned how to trace a parallel light ray to cast the shadow from an important point in your drawing. All right. Then we expanded that knowledge to cast the shadow of a line, a plane, and a solid. And I put this altitude and azimuth drawing here to remind us that these angles at which we're casting our light rays vary. All right, so in this case, let's look at the shadow of a line. This would be our altitude angle. All right, how high up is that sun in the vertical direction? And this shadow line here would be our azimuth angle, and that's where the sun is located in a horizontal plane. And those angles, those sun angles, can and will vary based on the time of day, the latitude, the time of year. So here's an example of the same geometric forms and the shadows they cast in an early spring afternoon versus a late spring afternoon. And when you're doing shadow studies of a real building, right, you'll want to take those into account. But here in Architecture 2A, when we're learning these basic skills, it is standard to assume a conventional direction of sunlight, right? And that's going to be coming from high, left, behind the left, our left shoulder, all right? And we're going to cast it at 45 degrees. All right, so basically it's along the line of a cube, so 45 degrees in this direction and 45 degrees in this direction. Let's take a look at some basic examples in plan view, shown kind of in a line across the top here, and elevation view. Starting with example A on the left-hand side. In plan view, it's basically a dot. So take a look at here in elevation view. What we're looking at is a line or a flagpole, all right, kind of sitting on the ground. Here's the ground plane. And the light is coming from high left back. So in elevation view, you can cast a light ray from point A down to the ground. And in plan view, here's our flagpole right here, A. It will cast from point A this way. All right. How do you know how long that shadow is? Well, it makes a difference where the shadow hits the ground. So you can see in elevation, it hits the ground right here. You can measure that distance or transfer it to your plan and then draw your shadow from point A to where it hits the ground. In this example, the flagpole is too far away. The shadow doesn't hit the wall. You can see that right here. It doesn't hit. Right? So in elevation view, take a look. You can't see the shadow at all. Let's move on and take a look at examples D and E. These are also kind of flagpoles. They are long, thin lines, but they are horizontal. And so you can see them right here in example D. In plan view, kind of it's poking out from the wall. And you can see it in elevation view right here. So we're just looking at the end on little circle. Example E looks the same in plan view, but take a look in elevation view. It's actually quite a bit closer to the ground. So how do we find the shadow for our flagpole D? All right, we're going to cast our 45-degree line here and bring that measurement down to the elevation view. We'll cast our 45-degree shadow line in this direction and then draw our shadow between these 2 points. Right? In this case, the shadow is cast entirely on the ground. Sorry, I said that the wrong way. In this case, the shadow is cast entirely on the wall, so in the plan view, there is no shadow. We don't see it at all. But that's different for example E because it's so close to the ground. So what you can do is in elevation view, cast the shadow until it hits the ground, transfer that measurement up to your plan view, right? Then starting from point E, again, cast our shadow line until they connect. You'll see that on the ground is a little bit of the shadow for that pole. All right, our last example is from F to G. And this is a horizontal, like a curtain rod pole, all right? And it is set in front of the wall. So it's not touching the wall at all. And so in plan view, what we're seeing is the top of that horizontal pole, and you see that it's not touching the wall at all. And in elevation view, you can see right here, all right, it is not touching the ground either. So what's important here is that there are 2 points that we need to cast from, point F and point G. And we can do that both in plan and elevation. All right. First in plan, cast our 45, hit the wall, take that measurement down to the elevation, and do that again with G. In elevation, remembering that our light is coming down this way, we will find the intersection, and that will be the shadow point of F. Here would be the shadow point for G, and our shadow is going to be drawn connecting these two things. So those examples were all about points and lines. What about solid forms? Well, it turns out that a solid form is going to be bound by the shade lines of the object. And so how we do this is we start with shadows of significant points, right? End points of straight lines, tangent points of curves, bounding boxes for your cylindrical objects, etc. All right, we cast those shadows and then interpolate and find the outline of the shadow of your form. So let's take a look at this example. We have a plan view, again, on the top, elevation view on the bottom, and it looks like kind of a rectangular tower. It's tall and thin in elevation, and it's square in plan view. This is the same tower placed in 3 different locations with respect to a wall that's standing behind it. So first of all, we have our tower standing quite a bit in front of the wall. You can see that once you cast the shadow lines and bring them up to the plan, and you cast the shadow lines from the plan, that tower is not going to throw any shadow at all on the wall. All of the shadow is showing in the plan view, none in the wall. I'm going to skip all the way to the right, okay? And you can see that this one is touching the wall. And so again, we can cast that right here and bring it down. And we'll have a shadow that is entirely connected to the wall. Right? It does have some shadow in plan, and here's the shadow in elevation. Your middle example here is a little bit more complicated. And so this tower is close to the wall. So it's going to throw shadow in plan, and we will cast those lines. And it will throw shadow, in elevation. Right? We'll cast those lines and connect them. Notice that it's important to cast this back corner of the of the tower, even though we can't really see it right here. Those are all very simple examples, lines, points, rectilinear forms. How do we do this for a complicated drawing? Well, it turns out you just take it piece by piece. Break it down to essential forms, all right? And you can then cast the shadows of each individual piece, and here's an example of it, all right? And then connect them together. For example, over here, connect these complicated shadows together to create your whole form. How do architects use shadows in their orthographic drawings? Typically, we use them in elevation. All right, so here's a couple of examples. We use them to show depth of field and add realism and interest to our architectural elevations. They're also commonly used in roof plans and site plans, and here's a couple of examples of that here. So in this video, we just walked you through how to cast shadows in orthographic views. Notice that it took both a plan and an elevation. We needed all of that three-dimensional information to cast shadows in our architectural drawings.